So for the applied problem this week, you'll want to use the z-score formula that we've been doing in Newton. We're asked to calculate a z-score in part 1. So here's the idea. It's the number, here we call it x. We subtract it by the mean and divide by the standard deviation. Okay, where x is the number that you're trying to convert to a z-score. The mean is obviously the mean of your population or the mean of your sample, and then the standard deviation. So for this problem, I've changed the numbers. My value I'm trying to convert to a z-score is 0.88. The mean of my patients is 1.42, and the standard deviation is 0.25. So it's just important to do the numerator first in the z-score formula, right? Which I've emphasized with parentheses there. Got to do the parentheses first and then conduct the division. Okay, so if I divide those two, get negative 2.16. So that's our z-score for part 1. For part 2, assuming it's normally distributed, that means we get to use the z-score table to help us calculate probabilities. What's the probability that a randomly selected person has a smaller EA ratio than the patient in question 1? So a z-score of negative 2.16 is to the left of z equals 0, obviously. And z equals 0 is the center of the normal distribution. When you convert your values to a z-score, you've recentered it at z equals 0. So negative 2.16 is over here. So if the center represents the 50 percentile line, then we should be expecting a small probability over here, right? And that's where we're going to use our table. You could use the table provided in the textbook, or you could just type in z-score actually to p-value calculator. We're not calculating something called a p-value yet, but I think the one I really like the easiest is right here at the top of that Google search. So you can probably, here I'll zoom in so you can see the address. Well, that's not the full address, is it? Here's the full address up top here. Okay, so in case you can't find it in Google, you can type that in, or you can just type in z-score to probability calculator, and you should be able to have something come up. So the website says that we're supposed to put our z-score in here, and I think it was negative 2.16. Let me double check. Don't worry about the significance level. It's one-tailed. Make sure that's selected, because the question is the probability. It said smaller than, right? To be smaller than something, you got to be less than something. So that's one direction. If it said, what's the probability that you get a score that's I guess I don't know how you would phrase this one for two-tailed, but if it's a two-tailed test, that's usually when we do hypothesis testing, where we just ask if there's a difference between two values. This one says smaller. That's why we're using the one-tailed. And then it says something called a p-value. For this, for what we're looking up here, that's the same thing as what you'd find in the z-score table. That's the probability we want, 0.015. And that makes sense based on our analysis before, right? Something definitely less than 50%, should be pretty small. So there it is. It's a 0.015 probability, a 1.5% chance that a randomly selected person would be that low. Part 3, you're just repeating the steps. Except now we're putting 2.31 in for the value we're trying to convert. Same mean, same standard deviation. Divide that by 0.25, so it's 3.56 is what I got for this one. And so this question asks you to calculate the z-score and to also calculate the probability that we have a higher EA ratio. So I made up the numbers for this one, but the actual data set I've given you is an actual medical data set from real people. I think it might be from Pakistan. I don't remember. I don't think it was US. Okay, so 3.56, that's definitely going to be bigger than 0. And then the probability should also be really small here. So to figure that out, we're going to go to our calculator, and 3.56. What your calculator does is when you click one tail, it's calculating how much area under the curve is in that one tail. So this time I got a really low probability, okay? 0.000185. So that's the probability we need for part 3. Part 4, which one's more extraordinary? It's the one with the lowest probability, okay? For mine, A patient getting a EA ratio of 2.31 is pretty extraordinary, because the probability that you randomly select somebody and they have a higher EA ratio is really low. It's less than 1%. It's less than 0.1%. So that's pretty extraordinary, out of the ordinary, right? So the z-score, since the instructions say refer to the z-score, here's another way of saying it. The z-score is further from 0, right? This z-score is negative 2.16. That's 2.16 standard deviations away from 0, from the mean. This one's 3.56 standard deviations away. So this one's more extraordinary because it's further away from the mean.